because it says it's a straight line distance, so it means that it's the distance from ground to air.
Absolutely right. The airplane is in the air. So you must use a triangle to find out where it is on the ground, but then you must use a triangle to find out where it is in the air. So you must use two triangles. Louis, what was your first triangle?
It was 37 to 81.
So I assume Louis went 37 north as up and 81 east, and then drew that triangle.
Yes.
If the plane was on the ground, it would be right there, right?
Yeah.
Does everybody understand why? Because that is the point on the ground where the airplane is north and east of the airport. If the plane were on the ground, how would you find out where it was? How would you find the distance from the airport to the plane? Of course you would use Pythagoras. Would you use add or subtract Pythagoras? Add. So this, of course, would be the square root of 81 squared plus 37 squared, which, if I am not mistaken, is 89.1. No, 5?
05.
89.1. So 05 is 89.1. Is everybody comfortable with that?
Yes.
Right? Pretend Tyler is on the ground looking straight up at the airplane. To find out how far Tyler is from me, I go there, and do Pythagoras. Everybody cool? Excellent. The plane, however, is not squishing Tyler on the ground, is it? Where is the plane? Straight up from Tyler. So Tyler is going to look straight up. How far? 6 meters? The plane is only 6 meters above Tyler? He is a badass. He is standing on the runway with a jet only 6 meters above him? Do you know what would happen to you if that happened? You would go flying. You would fly.
Either you go flying or you get sucked into the engine.
No, you would not get sucked into the engine. The plane would fly right over you, and the turbulence would send you, whoa! And you would go flying. But so, how far up is he? Is the plane? 6 kilometers. Okay, there we go. 6. So the plane is up here, yes? Has the airport moved?
No.
The airport is not in the sky. It is not a skyport. The airport is on the ground. So this is the line that you need. You know this is 89.1. You know this is 6. What math will you use to find that? My good friend Pythagoras again. And will it be add or subtract Pythagoras? It will be add, and it will be what? 81? 89.1 squared plus 6 squared. And what will we do with that whole answer? Square root it, and I believe it is 89.4.
Can I use like a different way to do it? Like 81 squared plus 37 squared plus 6 squared? And square root it.
81.
Yeah, because I'm adding the...
81 plus 37
Yeah.
plus 6 square root. Did you get 89.4? I don't think that will give you 89.
89.3.
Yeah, it rounds up. Yep, that's fine. This is worth 2 marks because no matter what you did, you needed to be able to do 2 things. There's 2 skills here. You either had to remember Pythagoras. Well, you had to remember Pythagoras, and you had to be able to figure it out. So you're getting 2 marks there. Yeah? Okay. Any questions? Does everybody understand why it works? It's exactly the same as the question we had in our notes, except the question that we had in our notes looked like this. And you had to find this distance in order to find this distance. But instead of being flat, the second triangle was just folded up. There was the 6. Aight? Aight. Now, the next question is also going to be worth 2 marks because the math is one thing, and then you had to know how to apply it in headings. So I need the angle along the ground. So which triangle in my drawing there is the angle along the ground, the black or the red? The black. So I had this angle, 37, 81. This is north. This is east. So I need the angle that is east of north, which is right in here, yes? How do I find that angle? Seamus. I know I'm not looking at the right one because you didn't do it. He's going to tell me. Oh, why you got to be that way? All right, who else? Tan, what kind of tan? Shift tan of what? 81 over 37, which gets you 65. If you got that far, you get 1 mark. But that is not the answer, is it? Because if you look back on page 56, I showed you how to write these. N65 east. That gets you your second mark. And finally, the angle of elevation. Is that the red triangle or the black triangle? Why? Because it's the one going up. 6. And then you could have used either 89.4 or 89.1. And then you have all 3 trig choices available to you. And when you do that math, you find that it is 4 degrees when you round to the nearest degree. That is only worth 1 mark. Any questions about the airport question? Lovely. Question 6. There are 2 triangles again, so we are going to use 2 triangles. The first triangle uses this blue triangle because I wanted the height of the tree. What do you have? Who do I? Raul, what do you have? Yeah, sure, you can give me the height of the tree. Pardon? The tree is 60 feet 6 inches. That's what you have? 32 feet. There you go. The height of the tree is 32.5. How do you find it? You said 32 feet 6 inches. Okay, I heard 60 in there somehow. 32 feet 6 inches. Absolutely fine. How'd you find it? What'd you have to use? Which one? Tan, right? The opposite over the adjacent, so that is 52 tan 32, which gets you 32.5. Now, Raul was smart enough to say 32 feet 6 inches. That's awesome. Spectacular. If you left it as 32.5, that's still okay. You still get your 1 mark. Second one, total distance to the bottom of the canyon. Now I have the red triangle. Same thing, except now it's 52 tan 67. But that is not the right answer, is it? That is only the red part. What do I have to do with those 2? Add them. Now, when you punch this in your calculator, every single one of you is going to round this, aren't you? Yeah, you are. Right? And when you do this, you get, if I am not mistaken, 122.5. Now, then of course you would add them and get 155. Right? Now, that's worth 1, so you get 2 marks. If you got the 155. If you left it there, you lose a half a mark. Now listen to me. Again, I remind you all. Assessment is changing. If you did this, and added, that's going to get you 3 on the 4-point scale. Right? How do you get 4 on the 4-point scale? You don't round till the end. You do 52 tan 32 plus 52 tan 67 equals. You do it once and once only, and you round here. Okay? Again, it doesn't matter. If you want that 4 out of 4, you got to start thinking about things this way. All right? That is over and above. That shows true understanding of what is going on. Okay? Everybody is Gouda? Nobody is Swiss?
I'm cheddar.
Nobody is Jack? All right. Who haven't I picked on? Connor. What's your drawing look like for 7?
Two triangles,
Excellent. Okay. How far is each of the bottoms? They're each 50. Well done. What are the angles of elevation? Are they up or on the ground? Excellent. What are they? They are 8 and 13. I have a red tree and I have a blue tree. Which is the taller tree? Red. Why? Because the angle is steeper. Well done. So, to do this question, it is going to be red tree minus blue tree, isn't it? Now, if you do blue tree minus red tree, you're going to get a negative number. You're still going to have the distance, aren't you? Right? So it doesn't matter if you didn't do the right order. But this is another opportunity to do the work or show the higher understanding. You understand what I'm saying, right? You could find red tree round, blue tree round, and subtract. Or you could recognize that this is opposite over adjacent. So since this is the denominator, you know it's 50 tan 13 minus 50 tan 8. And you can do it all at once. And I forget what the answer is. So somebody needs to say it out loud. 1.5? 4.5?
I got 5 because it says
round to the nearest centimeter. So we're dealing with meters. So 4.5 meters means we need to go to one more decimal place, right? What is it?
I got straight to 40 centimeters.
4.516, which means technically the answer is 452 centimeters or 4.52 meters. Technically. Since we have a little bit of disagreement, I'll take a quick look. Well, I don't need to. I can put it on the big screen. It'll be out of 2. So we had 50 tan 13 minus 50 tan 8. 4.516. So 4.52 to be perfecto. Again, Eric, if you've shown me the work, do I give you full marks? Of course I do, because this is not calculator 10.
It's out of 2.
Out of 2. All right. These questions. So let's get a nice bright color that's easy to see. Let's use my good friend pink.
I hated this question.
Fernie Island. So I'm dealing with Armstrong Point, Roberts Point, Fernie Island, Coal Island. Right? So Fernie Island is 1,750 meters north of Roberts Point. Here is Roberts Point. Is that visible? Yeah, that's not a great color. Let's try that one. Is that visible? That's better. Fernie Island. Sim sim salabim. How long is that? 1,750. Because that's right in the question. The sailboat leaves Roberts Point and sails to Coal Island on this bearing. Let's say you forget how to do bearings. But the question does say that I'm going to Coal Island. So if I sail from there to Coal Island, you don't remember how it works, but I'm going at 16, then this in here must be 16 degrees, must it not? Even if you don't remember how to do bearings. So you have this triangle, 1750, and this is 16 degrees. And I want to know how far the boat sailed. So I need 2 more sides of the triangle, yes? Is there a right or a wrong way to do it? If I find one of the sides, can I then use Pythagoras? If I find one of the sides, could I then use another form of trig? So is there a right or a wrong way to do this question? No. It's how you choose to do this question. The way I would do this question is, again, I would like to do it all at once. I have a theta and I have an adjacent. I need a hypotenuse and an opposite, which means I'm going to use cos and tan, yes? Since this is a hypotenuse is always in the denominator, correct? So this would be 1,750 divided by cos 16. That gets me here, right? So I sailed that, and then I add what gets me the other side. Tan, sine, cos, what? Tan of 16, opposite over adjacent, yes? So adjacent is in the denominator spot, so it's 1,750 times tan 16. And then what do I have to add at the end? Yeah, so my boat has sailed and he's back home. It's the wind. Well, of course he's taking the long way. If you were sailing from a dock and you didn't actually sail, you didn't leave the dock. Why would you have a boat? You would just sit at the end of the dock. Abso-smurfly. No, much like you guys, he chose to do something, or unlike you guys, he chose to do something with his weekend. Sail to a couple of islands and home, not just go down to the boat and take a nap. I'm well aware. I ask you every Monday what you did. Your answer is always sleep. All right, and the answer, if I'm not mistaken, is something around 4,080 or some crap like that. I don't remember. Anybody got a number for me? You got what? 4,072. You got 4,072.32. Any corroboration? 4,069.16. Okay. Did you use all trig or did you use some Pythagoras? Okay. So you had some rounding in there. If I'm going 4,000 meters and you have done the work, do you think I, as the teacher, care that you were 3 meters wrong? 3 steps? No. All right? Everybody cool?
What's that question out of?
That question is out of 2. Now you're going to do it again with the next one. Except now we're going Armstrong, Kingfisher, and Curtis. So I leave Armstrong and I go up to Kingfisher at a bearing of 307. So here I am at Armstrong, and I head over to Kingfisher as soon as it thaws. I head over to Kingfisher, then I head over to Curtis, and then I head home. So that's the triangle with which I am dealing, yes? Swoop, swoop, swoop. This is 800 according to the question. And it says I leave at a bearing of 307. What is wrong with that number? What's wrong with 307? 307 degrees. Why is that a difficult number to use? Yeah, it's bigger than 90. Now, you guys, if you look back on the page, you know that north is 0. What would all the way around be? 360. Did I go all the way around? No, I only went around 307, which means what is left over in there? 53. So my triangle is really 853, and then I do the exact same stuff as I did before. So, cos 53, 800 over cos 53, plus 800 times tan 53, plus 800. And I believe the answer is 3,000 and something. 3,190, according to my good friend Louis. Out of 2. Making that whole page out of 2, 4, 6, 8. Who do we appreciate? Trig, trig, rah, rah, rah. What? Trig is awesome, you guys. Huh? Alright, let's use purple. And so, in question 9, I am trying to find that height. Yes? To find that height, I need 2 pieces of information in a triangle that includes that side. There's the triangle. Do I have 2 pieces of information? No, I only have 1. That this is 43. However, in this orange triangle, I do have 2 pieces of information. I have that this angle is 69 degrees, and I have this side as 30. So what can I do with the orange triangle to get me my second piece of information in the purple triangle? Tan, because it's opposite and adjacent. There's no hypotenuse. We don't care about the hypotenuse. The adjacent is in the denominator, so it's 30 tan 69 degrees. Now, if you do that on your calculator and you round off, you're going to get a slightly different answer, yes? That's okay. But I am going to say to myself, I know that this side is 30 tan 69, and then in this purple triangle, I need the opposite. So again, it's tan. Since that's the denominator, I'm going to be multiplying. So it's 30 tan 69 times tan 43 to get the answer. And I believe it's 73 meters.
I divided instead. I divided. So
It's 78? I don't know. I'm going by memory. We're happy with 73? Okay. That's 1. Actually, no, that's 2, because you had to do something twice. Sorry. The tower is supported by guy wires. What's a guy wire? Mr. Myers explained that in previous notes questions.
that's like the rope that's supporting the tower.
Excuse me.
It's attached to tower to the ground.
Tower. There's one wire that goes to the top. What's its angle?
32.
To the top.
Oh, 50.
58. Then there's another wire that goes not quite to the top. What's it? 37. I want to know 2 things. I want to know the height of the tower and the difference. What angle do I use to find the height of the tower? 58 or 37? 58. So, 58 is going to be tan. This is 9.8. Opposite over adjacent. So is it multiply or divide? 9.8, tan 58. That gets you whatever you need. I actually need you to do it this time, don't I? Because I want the height of the tower. So you're going to get an answer and round it there, yeah? To the nearest tenth of a meter. What is it?
15.7.
15.7. Great. Now, how do I do the difference? Well, I know the whole thing is 9.8 tan 58, and a difference is minus what? The red triangle, which we know is 9.8 tan what? 37. And then I round that one, and I don't know what it is. Let's find out, shall we? 9.8. Why did you get it wrong, Eric?
Because my calculator's in the wrong mode.
Ah.
I didn't realize it.
8.29, so 8.3. And that's worth 2 marks. 1 for the height, 1 for the difference. And finally, one of the world's longest suspension bridges crosses the Humber estuary in England. What's a suspension bridge, Mr. Myers? You're right, I never taught you that. But I have taught you that not knowing something is the exact same as knowing it, because the only difference between not knowing it and knowing it is 10 button pushes on a keyboard. And when you do that, you see that, or you ask somebody, because almost every bridge around us is a suspension bridge. The Lionsgate Bridge, the Golden Ears Bridge, the Port Mann Bridge, the Capilano Bridge is a suspension bridge, but it's not long enough to need a tower in the middle. The Alex Fraser Bridge. All of those are suspension bridges. What do they look like? There's a bridge, there's a tower, and there's wires suspending the bridge. I know, right? It's almost like the name tells you what it is. Who's that guy at the front of the room? He's a math teacher. Oh, he's a brain surgeon? No, he's a math teacher. What does that mean? He teaches math. It's a suspension bridge. It's a bridge that's suspended. 135 is the towers, and you had 2 angles. 10.8, 18.65. I need to know how long the bridge was, which means I need I need that and that. And what do I need to do with those 2 numbers? Add them. And then what do I need to do with those 2 numbers? Multiply it by 2. So this one, I need the adjacent. I have the opposite. So is that multiply or divide? That's divide. That's 135 over 10.8. Plus what? Now, you shouldn't even need to think about this now, right? Math's a pattern. If this side was 135 over tan of 10.8, what's this side?
135 over 10, 18.65.
And then what do you do with that whole answer? Times by 2, and it's something like 2,215. That's out of 2. Making the whole thing out of 2, 4, 6. 6 is 12. And 1, 2, and 5 is 19. I'm making the whole thing out of 23. Give yourself a score out of 23, and then while you are adding that up, I'm going to wait for a second, then we are going to have some discussions about the next couple of days for you people. So get that all added up, tell your neighbor what you got, or don't tell your neighbor what you got, whatever it is gets you through the night. All right, now, I have yes, of course you can. I have an announcement to make before we go on. If for some reason your class, Block D, I forget to upload a video, the video doesn't work, the sound isn't on it, there are all kinds of technical glitches that can happen since I use a free software to do this recording because I'm too cheap to pay for it. If that happens, from now on, I've told you up until now you can use any of the other blocks. From now on, you cannot use Block B. Block B, from today forward, is doing different math than you people. You may use Block A's. Everybody understand?
What about last semester's?
Or if you want to go back and find last semester's, you can do that too. But I can't remember which block was pre-diploma. Aight? Everybody cool? Okay, now, next thing you will notice. As of that, as a corollary to that announcement, that should make you be aware that you and Block A are very similar. And you will notice Block A has a few things written up here. All right? This applies to you guys. You will be writing your trig test on Wednesday. Okay? Now, some of you are going away on a field trip. I'm well aware of that. It is your job to solve that problem. Okay? Now, this here was an optional thing that they chose to do, and here is what I mean. I have a quiz ready. I have it. It's printed. Well, yeah, it's printed. I can give it out. They all wanted to have one more practice run of trig questions to see if they were really ready for their test on Wednesday, because of course quizzes do not count. It's 10 multiple choice trig questions, I believe, and I think 1 or 2 draw your own triangles. Do you want to do that tomorrow as well?
Sure.
Okay.
That would be very much appreciated.
So you are going to try a trig quiz tomorrow. And the last thing is the cumulative exam. And we are going to write that next Tuesday. Now, I've explained the cumulative exam numerous times. Is there anybody that is still in the dark about what that is? All right. The cumulative exam is one exam covering the first 2 units. It is split in half. You're going to get a percentage on the first unit, percentage on the second unit. If those percentages are bigger than the percentages that you got on the unit test, you get that grade. You cannot go lower, and the cumulative itself does not count for anything. However, what it does for you is it allows you to practice test-type questions, and you're allowed to keep it. Because the unit tests come back to me because every grade 10 writes the same unit test. The cumulatives, I made up. They are mine. I allow you to keep. Then you have them to study from at the end of the year. You don't have to come in and dig through my filing cabinets to find your particular Unit 3 test. Everybody understand? That will happen next Tuesday. Yes. How I use it is, at the end of the year, I look at your cumulative scores. I put them in to check my mark as quizzes so they don't affect your grade. But at the end of the year, I have 3 cumulative exams, and let's say the class average on the first one is 71%. The class average on cumulative 2 is 50%. The class average on cumulative 3 is 89%. Obviously, I need to spend some more time on cumulative 2 at the end of the year when it's time to review. That's how I personally use it. Everybody cool? All right. Announcements are over. It's all written up there. We're all good.
I saw there's a math contest.
Talk to Mr. DeVries. That's not me. All right. Now, next thing. Obviously, between now and March 13th, we must continue onwards. And we will indeed be doing so. So, Up until now, this course is entitled Foundations in Pre-Calculus 10, yes? In grade 11, your math options diverge to Foundations 11 or Pre-Calculus 11 or A&W 11. Now, Foundations, these 2 units that we have just done, are very important to Foundations 11 and very important to A&W 11. Since we have done 2 units that focus on topics that will be carried through in Foundations and in A&W, it is now obviously time to go on to the pre-calculus side of Math 10, which basically for you people means the following. A lot more letters. Yes, alphabet in math. A lot more letters and almost a complete lack of real life examples. Because now we are at the part where we learn the math that we can then use to model real life. So for the next little while, there will be no chance for me to say, this is how we would use this in real life. So don't ask until the 5th unit. So unit 3 and 4 are math. Math for the sake of doing math. Okay? Everybody with me? All right, I'm going to make my tea. You have a stretch and turn to page... Sure. 77 first. So you can have a look at the outline whilst I make my tea. Have a stretch, talk to your neighbor, do what you need to do.
Feels like we did this last year.
What are we going with?
Purple.
Purple? I don't have purple.
Green.
Green. And?
Left. Right, yellow. Left.
Left?
Left. Left.
Left.
Green passion fruit.
Have you had that one before?
I think I've had all of them.
This is no fun anymore. You need to get for this hat.
My birthday is coming up. Don't be shy.
Give them a new teeth.
3 to 5 minutes.
Give them like a new teeth thing.
Yummy.
What?
3 minutes, Mr. Myers?
Yeah.
And go.
Feels like we did that last year.
Okay. Moving it along to page 70. I have it as page 78. That can't be right. It is? Oh. All right. Okay. Now, everything we are going to do for 80% of the next 2 days is review for all of you. The only difference is, technically, in grade 9, you only had to deal with exponents of actual numbers. The difference in grade 10 is we had a couple of new exponent rules, and we add the concept of variable bases, which of course in math means a letter. Instead of 7 to the 3rd power, it's x to the 3rd power. Rules do not change. Just instead of writing a 7, you write a letter. Okay? That's it. So let's remind ourselves how these work with the numbers. What in math does this expression mean?
7 to the power 3.
It means 7 to the power 3. But what does that mean? It means 7 times 7 times 7. Right? You all know that. Now, don't feel bad At some point over the course of this unit, I'm going to say what's 7 to the third power, and one of you is going to say 21. It's okay. It happens every time. It happens in Mr. DeVries's calculus classes. It's just an automatic reaction. You see 7 and 3, it's 21. But of course you know it is not, because that is repeated addition, not multiplication. And the answer here, of course, is 343. Okay? Now, we are going to use what you already know to fill in the top of this page, and then we are going to use that to expand our knowledge. I'm going to use some colors. You are welcome to do so as well. The base, I have highlighted in yellow. Where in this expression do I find the base? It is 7. Now, this is where we start getting into the difference in the questions I am asking. What is the base? 7. What does the base mean? They are two different questions. You all got the fact that the base was 7. But what does that mean?
The number behind the power.
It is the number that is being multiplied repeatedly. Yes? Okay. Now, I already warned you that in grade 10, it's not always a number, is it? So we don't want to say number. In grade 9, it was always a number. But in grade 10, it's not always a number. So we are going to change this not to be the number that is multiplied repeatedly. We are going to change it to the expression. Please underline expression. Everybody cool? All right. Now I'm going to ask another question about the base. We've asked what it is, so you can all identify it. It's 7. We've asked what it means. You can all tell me what it means. It means 7 is going to multiply by itself 3 times. Now I'm going to ask you this. Where does it live relative to everything else in this expression? I need an actual description of the location. So you say the bottom. Okay. But then what if I said that? 1/7 squared. What would you say the base was? Right. So you can't say the bottom. To the left of the exponent. Okay. So that is important. I'm going to do something here. Only, and I'm going to underline twice, what is directly, and I'm going to underline twice, left of an exponent. And I've done that for a reason. We'll come back to it in a second. Everybody cool? Okay. So now I'm going to use another color. I'm going to get out my good friend green. The exponent is green. What is the exponent? It's 3. So that's what it is. What does it mean? Yeah, it's how many repetitions of multiplication we're doing. Excellent. Where does it live? To the right of the base, but we also write it in a special way. How? It's a little number up above the line, yes? Okay, so now we know that the exponent is the number of multiplications. And we know that it lives up right of a base. And it has a special name, superscript. If you see that written anywhere, superscript, super meaning above, script is writing. So literally speaking, above where you normally write.
If it's below,
Then it's something totally different. Then it's a subscript. You guys know that from science. Oh, okay. You also should know it from Science 10 when you balance chemical equations. The little numbers at the bottom, like Al2ClO3, those are subscripts. Aluminum chlorate. Yes. Okay. Some people find chemistry easy. Some people find it very difficult. It's counting. I find it counting. If you can count, you can balance a chemical equation. All right, everybody cool? All right. Then a power, what's the power? The whole kit and caboodle. A power, eventually, will have a cool purple square around it. And it is the base and the exponent. And how do we read it? It's base to the number exponent. So in this case, you all know this already, it is 7 to the third. Everybody cool? None of that's new to anyone, right? Now, take that knowledge, all this knowledge that you already know, and let's apply it to a couple of new situations. First one we're going to do is this. What's the base? X. What does that mean? X times X times X. Naughty. What's the exponent? 3. Good. Seems easy, right? Okay. Now I'm going to change it slightly to this. X plus 3 cubed. What's the base?
X plus 3.
Why is it X plus 3? I said it was directly to the left of the exponent. Because it's in brackets. What do brackets do? They group things together. So the base here is X plus 3. So what does it really mean? X plus 3, how many times? Thrice. Lovely. Now, what is this one? X. How are you? I'm good. I wanted a different color there. What is this one? X plus 3 cubed. Now what's the base?
3.
Just 3. So what is this really? X plus 3 times 3 times 3. Is everybody good? Okay. What about this one? Negative 7 cubed. What's the base there? Negative 7?
7.
Which is it? Oh, it's twin battle. It's like a bad video game. The good twin and the evil twin. I don't know which is which. Which is it? Who will win, the good twin or the evil twin? One says it's 7, one says it's negative 7. Choose your sides for this infinity war.
Which side is Seamus?
Negative 7.
I want Seamus' side. I want the pause.
Now they're fighting about who said what. You know, I've got video evidence. We could go back and
I
check.
can't hear them.
Oh, you could hear them.
Oh yeah, you.
What's the base?
Negative 7.
It's just
Kingston, you're just saying both of them and hoping that I hear you at the right time. You said positive 7 all the way along? Because you're on Team Seamus?
No,
You don't even know what I'm talking about.
If it's bracketed, then it's -7.
The base here is 7. Why? Because it's left to the exponent and there's no brackets. What is the base there? Why? The brackets hold in the exponent. Is everybody good? Is everybody good? Who won? I don't even remember now. You were the one that said 7? Okay. Okay, now, remember, 2 exponents get special names. X to the 2 is what? Squared. X to the 3 is cubed. Nothing else gets a fun name. It's not fair, I know, but what are you going to do? All right, now, it should take about 3 minutes to fill in this table. I remind you, evaluate means the final answer. Final answer with no exponents.
So then, wait, would put the -3 to the power of 3, would it be like -3 times 3?
I want you to try it. That's the whole point of this table. I'm going to fill it in 3 minutes. You've got somebody to work with. You've got all the knowledge. We just had the big twin infinity war. You've got everything you need to fill in this sheet. Try. Go. What time is it? It's 2:14. Good gravy. We're running out of time. Yes. Yes. I make you guys a deal. I have, if you allow me to talk almost right to the bell, you'll get out of here with no homework. You'll get out of here with no actual work to do at all. But you got to allow me to talk. You got to let me get to where I need to get to. Okay? I just wish I could take you people back in time 30 years. School was a vastly different experience when I was your age. It better prepared you to go out into the world. I'm glad, Eric. I don't know how to fill my own teeth either. You know what? I pay someone to do that. You don't have to. Everybody's so up in arms. We leave school. We don't even know how to do tax. Actually, you do. Because all you need to know to do your taxes is to be able to add, subtract, and read. You leave school knowing how to add, subtract, and read. It's a sheet of paper that tells you what to do. Write this number here. And then later it says, take the number from box 59 and add this to it. It's not hard. It's just time consuming. Which is why I choose to pay someone to do it for me, because my time is worth more to me. Every 2 weeks, I get more money. I don't know why people talk about running out of money. Every 2 weeks, you get more of it because you have a job. But you never get more time. I'm not trying to be deep. I'm just saying you never get more time. And yet every 2 weeks, my bank account miraculously grows again.
Mr. Myers,
What?
the only reason that the government doesn't do our taxes for us is because companies pay the government not to implement laws that make it so.
That sounds a little tinfoil hat wearing to me, Corey. Time is up. First one's easy. What's the base? 2. What's the exponent? What's that mean? 2 times 2 times 2 times 2? 16. Listen to me carefully. It behooves you, which is a $5 word to say it's a damn good idea, for you to be very comfortable with 2 as a base, all the way up to 10. 2, 4, 8, 16, 32, 64, 128, 256, 512, and 1024. It is very powerful in the rest of your math careers to be very comfortable with the number 2 and all of its exponents. Next, what's the base? 3. I didn't fool anybody. What's the exponent? So how many 3's do I need to write in here? 3 times 3 times 3. But how do I account for that negative? It goes at the very front. So what's the answer? Negative 27. What's the base here? Negative 5. What's the exponent? So what do I need in here? 2 negative 5's, because the negative is in the bracket. So what's the answer?
25.
Positive 25. Nice. What about this one? What's the base?
8.
What's the exponent?
5.
So how many 8's do I need in there?
5.
5 of them. Can you do that in your head?
No.
I can't, so you got to use the button on your calculator. Everybody's button is different, but you always follow the same rules. Base, then whatever your power button is. Some of you will have something that looks like a little mountain. It's called a carrot, not like what Bugs Bunny eats. Some of you will have this, X with a little Y. Some of you will have Y with a little X. And some of you on the newest calculators, which is the most embarrassing to math teachers, don't even use letters for all of them. They have X with a blank, or worse, blankety blank. Because people don't understand that X just means a number. So they have made calculators even dumber. And then your exponent. So in this, you would go 8, your power button, and then 5, and you get 32,768. I don't have that number memorized. I do not have 8 memorized with all its exponents. I just filled this out this morning already, so I remember. Next one, what's the base?
6.
What's the exponent?
5.
5. 6 to the 5th is 7,776. What's weird about this one? What's the base? Negative 1, because the negative is in every one. And there are 7 of them. So it is negative 1 in brackets to the 7th. And the answer? Negative 1. 10 to the 3rd. 10 times 10 times 10. 1,000. 10 cubed. X cubed. Base is x. Exponent 3. X times x times x. Can I evaluate it? No. It is x cubed. Because you don't know what x is. You have to leave it. 2 to the 5th. Okay, that must mean I need 5 2's. Wait a minute. 5 2's? How do I get a negative? I got to put a negative in front of it. So this must be negative 2 to the 5th. Not negative 2 to the 5th. Does everybody understand the difference? Now, 9 and 9. There's 2 of them there. What's one way to make 9 from multiplying? 3 times 3. 3 times 3. So that would be 3 and an exponent of 2, yeah? What else can you do with 3's to make positive 9? I could do negative 3 times negative 3, which would mean I could also have negative 3. So it's either negative 3 squared or 3 squared, yes? What's the other way I can do it? 9. It's not repeated at all. So the base is 9. What's the exponent? 1. 9. Do we ever write 1 as an exponent? No, because there's only one 9. Now, this is the trickiest one. What's the base? Negative 4, and I need how many of them? 6. Now, negative 4 times negative 4 is a positive. Negative 4 times negative 4 is a positive. And negative 4 times negative 4 is a positive. So that must be all positive, yes? But there's a negative out in front. So the answer is going to be negative 4,096. What's the base? Negative 4. Exponent is 6. What's the base here? 4. 1, 4, 4. At the bottom here, I need to remind you of this. Negative exponents to an odd power are always what? Negative. Negative exponents to an even power are always what? Come on, we don't have time for this. We don't have time for this. We have no time.
Why does that work?
I don't know. Are positive. Now, here is a mistake that you guys make. Is a negative out in front always going to be negative? No. You have to use your head. A negative out in front just changes the final answer's sign. Just like this one, right? The final answer was positive 4,096, but since there was a negative out front, we leave it as negative. If the final answer was negative with a negative out in front, we change it to positive. Gouda? Thank you for letting me talk right to the end. You have nothing to do tonight except prepare for Trig. Everybody's favorite math topic, right?
If I ran the math on this on Star Wars.